Welcome to Decoding LLMs, your deep dive into how large language models actually work. In this course, you'll explore the core mechanisms behind AI-powered text generation. We'll break down complex concepts into clear, actionable insights. By the end, you'll not only understand how LLMs function, you'll know how to use them effectively. What are large language models, or LLMs? LLMs are neural networks trained on massive text datasets. They learn the structure of language by analyzing patterns across billions of words. Some well-known examples include GPT-3, Lambda, and BERT. These models scale from billions to even trillions of learned parameters. They're trained using unsupervised learning, meaning they learn directly from raw, unlabeled text. The transformer architecture, the core of LLMs. At the heart of every large language model is the transformer. Its key innovation? The attention mechanism, allowing the model to focus on the most relevant words and context. As the paper says, attention is all you need. Transformers use encoders to process inputs, and decoders to generate outputs, layer by layer. With multi-head attention, they analyze different aspects of information in parallel. And to ensure stable training, they use residual connections and layer normalization. Data is king, training large language models. Training powerful LLMs starts with massive datasets, sources like Common Crawl, Wikipedia, and entire libraries of books, totaling over 10 terabytes of text. Before training, data must be cleaned, tokenized, and formatted to ensure efficiency and consistency. Diversity is key. Combining sources from different domains leads to a more robust understanding of language. And most importantly, quality matters. The better the data, the more accurate, reliable, and useful the model becomes. Training process, step by step. It begins with pre-training, where the model learns general language patterns from massive amounts of raw text, using unsupervised learning. Next is fine-tuning, where the model is adapted to specific tasks, using smaller, labeled datasets. Finally, reinforcement learning is applied. This phase uses human feedback to optimize and align the model's responses with desired outcomes. The magic of next token prediction. Large language models generate text one word at a time, by predicting the most likely next token based on context. They use probability distributions to make each prediction. To control creativity and variation, sampling methods like top K and temperature are applied. The model relies on a context window, meaning it considers only a limited amount of recent input to guide its output. For example, the cat sat on the most likely leads to Matt. Evaluation metrics, measuring LLM performance. To evaluate a language model, we use a variety of metrics. Perplexity measures how uncertain the model is when predicting the next word, lower is better. BLEU score is used in translation tasks to compare model output with reference translations. Rouge score helps assess the quality of text summarization by measuring overlap with human-written summaries. Finally, human evaluation remains essential. It provides subjective insight into how useful and natural the model's responses truly are. Applications of LLMs, real-world examples. Large language models are revolutionizing many industries with practical applications. In content creation, they can generate articles, blog posts, and even marketing copy. Chatbots powered by LLMs are transforming customer service, offering instant answers and support. For code generation, LLMs assist programmers by providing code snippets and helping with debugging. And in language translation, LLMs break down language barriers, making communication easier across the globe. Challenges and limitations of LLMs. While LLMs are powerful tools, they come with several challenges and limitations. Bias and fairness remain a concern, as models can unintentionally reflect societal stereotypes. Another issue is hallucinations, where the model may occasionally generate false facts or inaccurate information. The computational cost is another factor to consider, as training and using LLMs require substantial computational resources. Finally, ethical concerns arise, including the risks of misinformation and the potential creation of deepfakes, which can have serious consequences. The future of LLMs, what's next? The future of large language models holds exciting possibilities. Multimodal models will integrate not just text, but also images and audio, creating a more dynamic understanding of the world. Explainable AI is on the rise, aiming to make models more transparent and easier to understand, enhancing trust and usability. In the future, we'll see the development of smaller models, optimized for efficient use on edge devices with limited resources. And with continuous learning, models will evolve and adapt to new data, improving over time without needing to be retrained from scratch. Thank you for watching. Happy learning!